Today I will talk about tuning of hyperparameters in machine learning. Machine learning include parameters and hyperparameters. Parameters are nothing but coefficients which are estimated from the machine learning algorithm, and hyperparameters are part of machine learning algorithm. I will be illustrating the Python codes using the Sci-Kit library or sklearn. I will describe tuning of hyperparameters by using three options. One is using cross-validation, and the other two include automatic hyperparameter tuning using GridSearchCV and Randomized SearchCV. These are part of sklearn library. So first of all, we will load the data. I will be using the inbuilt data from sklearn, the iris dataset. My X variable, uppercase X variable will be iris data, and the lowercase y will be the labels or the target variable from the iris data. First, I'll describe the manual tuning of hyperparameter using cross validation. We will be using cross-val score from model selection and k-neighbors classifier. This will be our algorithm for classification. First of all, we define the range of the neighbors. I'll set it to 1 to 24, and this is the empty array which we declare. Then for each k in k range, that is from 1 to 24, we will be using the algorithm, and then we will store the cross-val score of the model. So these are the final scores. So these are the final scores. So for if we use one neighbor, then the score is 96%. If we use two neighbors, score is 95%, and it is increasing, and it goes up to about 98%, and then it again decrease a little bit. So these are the results of using various number of neighbors in the classification algorithm. Now we will tune the hyperparameters using GridSearchCV. We will import GridSearchCV, and we will also plot the results. So similar to previous example, first of all, we set the k range or number of neighbors. It is from 1 to 24, and our algorithm is k neighbors classifier. Then we define the GridSearchCV. This is our k neighbors classifier. The param grid or parameter grid is this dictionary of number of k neighbors. This is CV. I'll set it to 10-fold cross validation, and the score which I'll consider is accuracy. So I fit the GridSearchCV, and then I'll assess the mean test score, and I plot the mean test score versus number of neighbors. So these are the scores. Similar to the manual scoring using cross validation, we get exactly similar result. Initially, the accuracy is about 96%, then 95%, then it increases, similar to our previous example, then it gradually decreases. So we can set our number of neighbors somewhere between the 13 and 20. So this is how we can tune the hyperparameter or number of k neighbors in this classifier. Now let us see tuning of hyperparameters using randomized SearchCV. So if we increase the parameters, then the use of GridSearchCV will be computationally exhaustive. So we can select the parameter options randomly, and we implement this using randomized search CV. So this is how we define our parameter dictionary. We are using two parameters, that is number of neighbors and then weights. And weights can be either of these two, uniform or distance. This is our classifier, k neighbors classifier. And then we set the randomized search CV. This is our classifier. This is parameter dictionary. This is tenfold cross validation. This score we will use the accuracy, and the number of iterations for randomized search CV. I'll set it to 10, and this is the random state. And then we accumulate all the best scores. So the result is, so this is the result. So the result is almost 98% in every random instance of our randomized search CV. I have tested it 20 times. This is the code for setting it to 20 times. So these are the 20 randomized instances, and the accuracy we get is the best accuracy we get in these 20 instances of tenfold cross validation. We get 98% accuracy. This is another example. If we use the support vector classifier, and this is the parameter dictionary, and these are the parameters. So there are 4 parameters. So this will, if we use GridSearchCV, it will be computationally exhaustive. So I'll be using randomized search CV, and then I will identify which combination of the parameters is best for us. So this is the parameter dictionary which we have defined, and similar to previous example, this is our classifier, support vector classifier from SVM library. And this is setting of randomized search CV. This is my classifier. This is parameter dictionary, which is here. This is tenfold cross validation, the accuracy score, 10 iterations, and random state 5. And I will be doing it 20 times. So this is the print of best parameters. And this is the print of best score in every 20 instances. So these are our results. The best parameter include the linear kernel with gamma of this, degree 21, and C value of this. So it is almost similar, as we can see. It will go up to 20 values because we have iterated it 20 times. So this is how we identify the best set of parameters, or we tune the hyperparameters of our machine learning algorithm. This is all for today. Thank you very much.